All right, thank you. So it's recording, we're good to go now. We're gonna make progress. You don't have to watch, I checked.
Okay.
Should we be good? Maybe check it in like 20 minutes, see if it's still red.
Yeah.
All right, everybody, we're here to, now we're maybe the fourth, fifth most significant thing in the work of Mirza that's very important to slow down and take note of. And that is, he is referring to the A-B linkage here. He says, the equilibrium process suggests that A and B, whether small chemicals or humans, interact to establish the A-B linkage. But the reverse process of remaining as individuals like A and B is also operative. So we can go A plus B can form AC in the forward process, but it can also reverse and form single species again. That's correct? So then right here, we're going to take a look at shortly a short little review of the history of human chemical bonding theory. Because as far as I know, this is the first person in the history of humankind to use the dash symbol between species A and B. So this is symbolic of the force that's holding or uniting the two things, a chemical bond. And Mirza thinks of it as a dipole attraction. So if we look at here we have just a generic symbol of the human chemical bond. Man and woman have a bond together and form together in a relationship. And by definition, in human chemistry, human chemical bond, AB, is an electromagnetic induced stabilizing attractive to repulsive field particle mediated cohesive force functioning to hold human molecules, that is people, together into bound state entities, such as marriage pairs, friendships, work units, and social collectives. So historically, Mary Mesny was one of the first persons to speak. She says in 1910, each human molecule has various bonds of affinity. So prior to the development of, in the early 20th century, of the Lewis dot structure and the covalent bond and exchange force theory in the first decades of the 20th century, people used to speak of bonds as affinity bonds or affinity forces of affinity. So he says each person or human molecule has various bonds of affinity, satisfied and some unsatisfied. If his or her bonds of affinity are not met by the affinities of some other molecule, he or she is apt to be very unstable, chemical. So now, here's an example of some different bonds. The more linkages you have, the stronger the bond. And of course, we have the work of Goethe in 1809. He developed chemical bonding theory. So here's Wilhelm Cullen was the one who first developed these chemical reaction models. In 1756, in his lectures, he didn't use A, B, and C, but he used the alchemical symbols like this. And he said this is the bracket, or the crochet as he called it, is the symbol for the force, the bonding. This is the original bonding bracket. So now we use these symbols, these dashes, but in 1756 he said this crochet is what holds species A and B together, and the reaction arrow is the dart as he called it, that represents the force of affinity. So A has more force or affinity for C than it does for B, so that if C is introduced into the system, A will detach from B and by the force of affinity react with C and form a complex. So in 1775, Torbern Bergman introduced letter symbol style notation for reactions. So instead of using the alchemical symbols, he started using, instead of this symbol and this symbol, he substituted AB. It reacts with, if it's introduced to this species, B is going to precipitate out as a liquid, and water, if this is in the aqueous solution, A will form with C and go into the gas phase. And here's what the symbols look like. So when Goethe came along in his mind, he developed his novel elective affinity such that people who had bonded brackets, and if somebody came into the system that had more affinity for whoever they were commonly bonded with, they would detach to the affinity force. And so he developed this, he wrote 36-chapter novel using these Bergman style affinity. So in modern terms, if we have AB introduced with C, the A will bond with C and displace B. And now we use these symbols like this. So Mirza is the first person in history that I'm aware of, which pretty much means that he's the first person in history, because I'm pretty much aware of everything ever written in physical-chemical history, to use the, he says that A and B can have an equilibrium reaction, and then he says, he talks about the AB linkage. And so he says this is the first person in history to use AB notation for chemicals as well as people, and also to speak about the chemical bond. So that's very, in 2002, Jürgen Memke's, he wrote an article in Germany, in chemistry called in Germany called The Chemistry of the Social Bond, but he never used any symbols. And he talked about how Jürgen Memke's, remember, is the guy from Germany who came to the lecture, the conference in last year. He's the one that started the Physico-Chemical department in Germany. And he produced a few graduate students who was use this kind of logic. But he, over here he says that the, let me see if we can adjust this here. He says the state of a large stochastic or chaotic system of n objects can be calculated by the Lagrange Principle. It says that the summation, the Lagrangian of the system is going to tend to a maximum. P is the probability that is to be maximized under the system of condition E, and T is the Lagrange ordering parameter. L is the Lagrange function of the system that may be far away or close to stability. At equilibrium, the Lagrange function is at maximum. In the natural sciences, E is given by the chemical bonds, and the negative Lagrange function corresponds to the free energy from which all thermodynamic states may be calculated. Then he says, in social system, the Lagrange principle corresponds to common benefit, and the function E represents the social bonds. So you can read his article, but he doesn't use symbols as Mirza does here. So
this function E, he says the function E represents the social bond of systems. It may with an element of uncertainty.
Say that again? Oh yeah, give him the,
this
you need your tool, Mirza.
Represent social bond. We represent the social bonds of the system with an element of uncertainty.
What do you mean by that?
This is a probability that a social bond will be formed.
Well, yeah, probability, there's always uncertainty.
You cannot predict it.
Yeah.
You cannot be certain that this social bond will be lasting one, this will be permanent one, or will it take place at all?
Yeah.
It may function in social system, it may come to the benefit of the common benefit, but with an element of uncertainty. Not always.
Yeah. There's
not always.
What I think he's trying to say here is that the Lagrange function is kind of the precursor to the Gibbs function.
The Lagrange function is not a has not been tested on the humans.
No, but at least the point here is that you used just the symbol. You talked about the AB linkage. Now he's trying to expand on 2002. He's trying to expand on this. He wrote a draft paper and kind of just sketch out the ideas, kind of think about how the social bonds of the system would work in human terms. So then I started working in 2003. I began to grapple with human bonding such that the human bond is a chemical bond, such as described by Linus Pauling's 1931 article, The Nature of the Chemical Bond. So in my mind, I wanted to explain your AB linkage in terms of the same model that Linus Pauling derived nature of the chemical bond. That's in terms of molecular orbital overlap theory.
But Linus Pauling always says, talks about the ionic bond and the covalent bond and all those things.
Mhm.
So it is a covalent bond that is a permanent bond. It's not a permanent bond. It's more stable. There is more stability in the ionic bond. There is a stability, but that is.
You're talking about bonding and anti-bonding orbitals.
So the bond energy in these cases is sufficiently high, but then when you apply it to the human system, then the uncertainty will exist.
Mhm.
The bond formation is not likely to be the same order.
Well,
There will be ionic bond, there will be covalent bond, and there will be dipole moment bond,
mhm.
and there could be only attractive and force, that type of thing.
Okay.
So among the so many bonds, it will all depend on the species that are interacting.
Mhm.
A highly polarized substance has a strong bond with a weak bond, with
Yeah. But you agree-
with a weak element.
You agree, though, that your concept of the AB linkage, the dash between there, that's a symbol, there's amount of bond energy
Yes.
that's in there. That's
There have to be-
measurable bond energy.
There have to be quite a few dashes,
Okay.
quite a few dashes.
So here's how I came into the concept of the human chemical bond. I wasn't even thinking about bonding before 2001. I just had in my head that A, the male species, plus B, the female species, react to form C, the child. And I just want to understand how you do this in terms of Gibbs free energy. So then, in 2002,
Yeah, it will bring a child only if they want it. Now the scenario is different.
only if the Gibbs free energy is.
In permissive society, it's not likely that a child will be born.
Well,
They enter into agreement that we will live together.
let me just say though that we both agree that whether it's promiscuous society, ordered society, or it's a chemical society, the determining factor on whether the reaction will occur is that the free energy has to decrease. Correct. Okay, so that we agree on that. So in 2002 or 2003, it became apparent to me that I was leaving out an important component of that's the AB bond. And that had a certain free energy with it that goes over here that I was missing out. So I had to develop in my mind a model for this. I was leaving out this whole, there's a bond energy here. This is the husband and wife bonded together. For example, you've been married to your wife for 57 years.
57, okay.
Yep. And so this is, there's a certain amount of Gibbs free energy there's a Gibbs free energy in here. This is you, A, and your genetic component. This is your wife and her genetic component. And so you collide in time and chemically react to form the married couple and say your first son. Your son was born first or your daughter?
That may be true about a permissive society, but in our society it will not work. A plus B will not interact with CD.
No. This is
In
not.
the traditional
This
society,
is this is.
AB plus CD is not possible.
No. This is you understand this diagram. This is one person. This is another person. This is not four people.
Not a couple.
No. This is a man and his sperm. This is the woman and her egg. Their genetic component, their DNA. So this is one person. So A departs from his sperm. C departs with her egg. So B and D come over here and form the child. The egg and the sperm combine form the child. Now the A is the male and C is the female. So they bond to form the married couple. So when these two things collide, when you meet your wife, there's a bond energy here that's stored. Gibbs free energy is stored in the bond. And it was Fritz Haber that worked out the first theory of bond energy in terms of thermodynamics. So in my theories, I was missing all of this Gibbs free energy at the initial state that goes over the metastable complexes, go over the activation energy barrier. Some of it is stored in the bond between the married couple. So I needed to develop a theory of the. Do you understand what I'm saying? Of I need to understand how is Gibbs free energy stored in this bond. So I had to go down here. You see, read this over here. In this reaction, A and C are male A and a sperm B. C and D is the female and her egg D. At the second, say first sight, when you first saw your husband or wife, and A and C is the bonded in marriage parental structure, and BD is the 15-year-old child precipitate when it starts to detach from the parental structure. So this is, once it detaches from the parental structure, it goes off in its own individual synthesized molecule. So when you were 15 years old and you left India, this is you as in when you became a man. That's what this is about. But then, so it took me a while. I started thinking of the human bond in terms of human molecular orbital theory, which is this right here. So I started, like Linus Pauling speaks about, so if you look at a person from a point of view, this is your home here, you go in your orbital movements, you go shopping, you go to school, maybe go to the restaurant, you go have a new home, you go to work, and then you rotate in these in your daily planes. So this is your first nodal plane, second nodal plane, and third nodal plane. So this constitutes what's called the molecular orbital view of a human, of one person. If you say you take a GPS watch, or you track their phone, and they're moving in these orbitals, then, so this is what I was working on at, so for example, so here you have, these are some of the first sketches I worked out. So let's say a person moves in their orbital. It's kind of like electrons moving in their orbitals around the hydrogen atom. So you have your home here, work, friend's house, another friend's house, maybe you go to the mall or the grocery store. Then you now here we have transition state theory. So when you first you collide with, say you meet your wife, you meet her at school, and you go through your daily orbital, and your orbitals overlap, and she goes to the same college you go to. So then you start meeting here. Then you find out you have some friends in common. So you start rotating your friends' orbitals. Then you combine, fuse into the dihumidide molecular orbital. So originally I was thinking of chemical bonds in terms of Linus Pauling's molecular orbital theory. But then, history of human chemical bonding theory.
इसका भी समझ लीजिए आप चलेगा इसका भी समझ लीजिए आप चलेगा
So there's Goethe, there's you, and then there's there's Jorgen Memke's right there with his system. Then I started developing, first I started working on field particle exchange model of human connections. So the photon, this comes from exchange force model of electrons and protons. The photon is the electromagnetic force, the exchange between the particles, and it changes the so I started thinking of it in terms of electromagnetic bond is what holds the, when you spoke about the AB attachment, this is AB and this is the bond, and I started thinking of it in terms of, so some of that, once you read, so then I got to the point here where you have the dodecabond model of a man and a woman. This is their social orbitals. They're bonded at 8 enthalpic points. So one thing you want to do when you write your second edition of book is speak up a little bit more about what you believe about enthalpy. So there's Gibbs free energy is composed of enthalpy, entropy, and temperature. So
Yeah, the product is entropy driven. The reaction, male-female interaction, is entropy driven.
Enthalpy.
That is, the child is a product of energy.
Mm-hmm.
The child production is entropy driven. The product is entropy.
And which one is enthalpy? Which one is H? H for enthalpy. S for entropy.
I'm not talking about this age.
No? You're talking about S?
The entire reaction
Uh-huh.
in the womb that is taking place, whatever is taking place there is entropy driven.
Entropy. Well, I'm saying
Energy of the fire of the male is being wasted through this sperm and being engaged
Mhm.
by the egg of the female.
Okay.
That reaction is also entropy driven. The fertilization
Mhm.
is entropy driven.
Okay.
The
Yeah.
energy is
I get what you're
spent.
saying.
Yeah.
But so anyways, the point here is that Mirza is one of the first person to speak about the AB linkage and use notation for the human chemical bond, which is a good step in the right direction.
Mm-hmm.
Historical. So now.
The question of primal.
Let's see where we are here. Okay, what about this? Page 75. You speak about the ABC society. Right here. What does this mean? What is an example of an ABC society?
Very strange.
That's a trimer society?
I don't know what type of drink I had taken at that time. But this is very neat.
Okay.
Oh, good. Oh.
We'll go to, let me see what else we have here.
I'm still not thinking.
No, I think it's interesting.
How could I come back? What was the frame of mind?
No, you probably, I think what you said there.
I had by that time visited quite a number of places.
Okay. Let's see what you have here. And page 76, you say, in the physico-chemical sciences, the major component, that is, the solvent determines the properties of the solution. And so does the
Sorry
major
again.
group of society determine the character of its members.
This
So-
could have been, this could have been imagined only by a person who had lived in Karachi.
Yeah, ABC society.
In Karachi.
All right. Okay, on page 79, you say, You say in this model being discussed here, molecules are the smallest particles of the individual substances and are being treated analogous to the individual components in a society. So people in society, in your mind, are modeled as human molecules. That's
It's
correct?
a molecular model. It's a
Okay.
molecular model.
It's proposed in order to simplify.
Molecules are the smallest particles of an individual substance. Okay,
Uh-huh.
one family,
Mhm.
and are being treated analogous to individual components of the society. The other units are the individual components of the society. Right?
So this
one
is-
molecule interacting with the
So in order to simplify the
In order to
assumptions,
simplify, it is proposed to count the molecular weight as the number of individuals forming the group, those of A and B or C. Suppose XA is the fraction of majority component A, XB is the number of component B, XC is that of C in the diameter of B. So this component will go for B, that will form C with 3, and interspecies forms like AB, AC, BC, and ABC. The change of property in A would be given by 10. That means, no, it should be down below. This one.
okay. Partial
These are all
pressure.
changing. XA,
It's Henry's law.
XAA, BB, CC, ABC, BBC, and all that.
Okay.
So that will be PXB will be P I PI XI upon BXB, and this one and for the second for the V's, for the C it will be like 12.
Okay, how about you explain this one down here? You say, here I have a question.
Yeah, one could imagine the above equation.
Let's hear explain this here. What is munafakat?
Munafakat is dichotomy
The what?
or hypocrisy.
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 Okay. So explain your equation here. The morality of society
Morality of the
ABC.
society ABC will depend on the morality of A, number of persons, morality of B, number of persons, morality of C, number of persons. Then the whole thing will come to this plus this equal to something. What does it amount to?
So what
Is, in that case, this whole is clear. The morality of the society ABC will depend on the morality of A, number of persons, and then whoever is in majority.
So give me, in this case, this is the
The morality
Hinduism.
of A,
Say in the
the morality of ABC will depend on the morality of the majority.
Okay. So for example, in India, what would this be? This is Hinduism,
Hinduism will dominate.
Islam. What is the third
In
morality?
that case,
Buddhism.
these people, this will be dominant. This will be dominant feature. These people will have to adjust to the morality of these people. If they cannot, there will be conflict. If they cannot, there will be conflict. So in case of morality, the identity will certainly be lost,
Okay.
because interaction starts with morality. You lose your identity once the